Okay, so we're going to continue here with our maze solver and do some things to kind of, so we have a little more fine control so we can actually use it to solve a maze. The first thing I want to do though is change some of the formatting here. So specifically for the floats, I want to change this to be 5.1F. And this will give us always one decimal place after the there you go. Still not quite though. I would like to see I'd like to see that decimal stay lined up. Okay, so we're going to change this. We're going to set this to be 6.1 fixed width. Okay, let's see how this does. Run that. And let's see. Yep, looks like we got our decimals lined up. Perfect. Okay, so that is done now. Okay, and the next step we're going to do is we're going to basically do some work here so that instead of it flopping all over the place, it has a really fine range of control. And we're also going to be centering it. Okay, and so let's start by centering it. So what we're going to do is we're going to make a function, and this function is going to basically take the let me stop the operation here. It's going to take this value here and map it to an angle, but we're going to kind of constrain that angle so that we don't end up going that full from 0 to 180. Instead, it'll be like plus or minus 5 or plus or minus 10, and we can set that. And so we're going to start by making a function. So we'll define that function right here, and we'll call it ADC U16 to angle. Okay, and what we're going to pass into this is basically the ADC value. So ADC, we're going to pass into this the center position, and we'll have that be a default to 90. And then we're going to also pass into this the max offset, which we'll set to be 15 by default, but then we'll update later. Okay? And essentially, the way that we're going to handle this is we're going to take the ADC distance from basically the position on the ADC axis and map it to a distance between 90 plus or minus 15. Okay? And so what we're going to do is we're going to calculate the angle by doing this. We're going to multiply. Okay, so actually what we're going to do is we're going to take our ADC value and we're going to divide it by the max ADC value, 536. Okay, or 35 rather. And then what we're going to do is, once we've done that, we're going to multiply it by twice the offset. And what this does is it kind of puts it on in this kind of range. And so essentially what this does is it's going to take this value here. Let's say it was somewhere between 0 and 65,000, and now it's going to put it between 0 and 30. Okay, because 2 times that offset here is 30, and we'll adjust that later. And then what we want to do is we want to then center it, and so we're going to add to that the center position minus that max offset. Okay, and we have some parentheses here just to help understand what's going on. They're not actually necessary to do the calculation right, but just to help us distinguish it. Okay, now we do also need to kind of constrain it. So what happens if this value somehow ended up outside that range, right? We would end up with if this ADC value was negative somehow or greater than 65,000, we could end up in trouble. And so we want to also constrain this. Okay, and so we want to no, we don't want to copy that. All right, so from here, okay, so if we do this, if we call this function with reasonable ADC values, we should get out an angle that's within that range. But just in case, what we're going to do is we're going to say if angle is greater than center position plus the max offset, we're going to set angle equal to center position plus max offset, and if angle is less than center position minus max offset, we're going to say angle equals center position minus max offset. Okay? And then we'll just return our angle just like that. Okay? And so now we do this calculation here, and this will replace that calculation. And so here what we're going to do is we're going to delete that, and we're going to say ADC U16 to angle, and we're going to pass in that X val. Okay, we'll copy this right here, Y angle and Y val. Okay, and now we run this again, and what you're going to notice is when you move it, that range of motion is more constrained, and if you look here, like that angle is only moving by about 15 degrees. Okay, now if you look at mine, you can see me hold it up where you can see it in the camera. It's kind of like at that center position, it's kind of like crooked. And so what I need to do is I need to center it. And so now we can take advantage of this center position and the max offset. And so what we're going to do is we're going to make some variables here. Okay, and we're going to call X center. And we'll just start with 90. And then we're going to do Y center, and that will be 90. And then we're going to do max offset Y, and we'll set it to be 15 max offset X equal to 15. Let me actually move this one above. Let me actually put up an X value so we have them grouped together. Okay, and so now we're going to tune these values based on our maze. And so I'm going to run this, and I'm going to move my maze so it's centered. And so I'm holding this in the center position. I'm looking at the X one, and you can see it's centered, and it's at 75.2. So that means I'm going to come over here to X center. I'm going to change this to be 75.2, just like that. Okay, and I'm going to run it again. Oops, I forgot to, let's do this. Let's come down here, and we're going to say center underscore position equals X center, and we're also going to say max offset equals max offset X. And I'll copy this down to here, and we'll change that to be Y and Y. And so now when I run this, you can see now it's starting at that position, and it's still not really centered. And so I need to move it over some more. And now it's about centered at, looks like 67.4. So I'm going to change this to be 67.4. Now I'm going to tune the other axis. This one's actually pretty straight. right here at 90. Okay, and then I'm going to tune this a little bit less to make this to be 10 degrees. Okay, and now let's try run it. And now it's pretty close. And so now when I move it around, it doesn't move that much. So if I hold it up here, you can see when it's like maxed out, it's got this more narrow range of motion here. And so now if I hook up, for example, a maze to it, I can solve that maze. Now, as you're doing this, you can adjust, like I said, these centers to get it centered. And then if you decide you want to constrain it further, you could drop this down to say like 5. Okay. You can just choose what you want that max angle to be. And as you constrain, it'll get really tight. But this is what's going to allow you to be able to then actually use this to solve your maze. Okay, and then we'll do some more building off of this. I like to try building like an auto solver, and then maybe we'll turn this into a class and stuff like that.